So let's start the session. So now morning we saw this report from the US, and now we will have the report from the other side of the Atlantic. Yeah, Eric, floor to you.
Okay, thank you very much for invitation to this meeting, which I think is a wonderful meeting, to Rohini and Swapan for organizing this, which good for the connection of India to Europe and US in two ways, I think, and also very timely, given the strategy we heard this morning from Snowmass and the European strategy, which is a bit more old news, but nevertheless, I think it's good to go over not just what it was recommended, but a bit the process behind it as well, and the mechanism, which gives an interesting comparison of process between the US and Europe. I was not in charge of this process, but I was a participant. And in that sense, as a council delegate for the Netherlands, I was also part of the strategy group. And so I can at least give you a bit of an inside view to some extent. So the goal is to give you a bit of background, go over the statements, and roughly what has been done with those statements until now. That's sort of the plan for the talk. So it is the process. It's the strategy update process. There's only one strategy that gets updated every 6-7 years. And it is the process by which the European particle physics community, including CERN, but not only CERN, also the Europe-wide, and its member states determines its strategy. Not a vision, right? It's a strategy. So there's really things to prioritize and to make a list of what you should do and what you should not do. It is a 2-year process. It's a well-regulated process, bottom up, maybe not quite to the extent that the SNOMED process is, but still, nevertheless, I'll show you roughly how. All stakeholders that can define themselves can give input. And as I said, it's not just a nice document that you put in a drawer now and then when you want to get inspiration you look at, but actually it's a serious strategy for guidance of policy. And at least it's a good quote generator. You see many quotes from the strategy are really you see in talks all over the place. It also gave me the impression, oh, this is actually taken quite seriously. As a theorist, before I got involved in these things, I wasn't that much aware of all of this, but I've seen now how it works, and also it followed. It's very impressive. So, but perhaps to understand a bit behind it, it's good to remind you of how CERN is governed, because it has some bearing on this. So the highest authority of CERN is the council, and it's governed by a president, and there's various subcommittees. And what the council does, it's responsible for all major decisions of the lab. So it approves large programs, adopts budgets, reviews expenditures, etc. These committees are standing committees that get rejuvenated, of course, regularly. And those are also quite international. There are 2 representatives from the US and from Japan on this, for example. They're all ad personam, so there's not a representative function. And the director general, of course, manages the lab together with the directorate. And formally, she is the secretary of the council. So that's the formal structure of the governance. And this is already enshrined in the, by now quite venerable CERN convention, which was not just there to govern CERN, but it was very much, and these days as well to remember, founded to enshrine science for peace. And it's something that is good to be reminded of, particularly, as I said, in these days. So the council has 23 member states, so typically 2 delegates per member state. Serbia was the latest full new member. And as I said, votes on all these key decisions regarding CERN and gives guidance on many more. There were 10 associate member states, among which India since 2016. Probably the next one might be Brazil. That would be the first one on the American continent. So, and these are the representatives from India that are representing India in the council. There are also observer states, Japan and the United States. The Russian Federation and China have been suspended for reasons that you all well know. It meets 4 times a year. There's all the council week. And this is an action-packed picture of what the council does. CERN, some numbers. The annual budget of CERN is about 1.2 billion Swiss francs. It's equivalent to a medium-sized European university. Organization like a small city. There was lots of other services. There was hostels, there was a medical service, there was housing, there was all kinds of stuff. There's traffic you deal with. And of course, the nice thing about CERN is that budget is more or less guaranteed, right? It is not that you have to go to Congress every year and beg for the money, or ask for the money, I should say. But so that gives a lot of stability, and that also makes a difference in how things can be strategized. The member states pay according to their gross national product. Associate member states typically pay about 10% of what the full membership would cost. India is involved in CMS, and Alice is very active in there. I think also in Isolde, and also in the computing, which is very important support activity, of course, and research activity by itself. But for most purposes, CERN should be seen as an accelerator and user facility. The experiments are not CERN, right? They are their own collaborations with CERN also as a member. And those are paid for by, well, the members of the experiment through MOUs. There's a lot of R&D going on, of course, at CERN, accelerators, detectors, but not only there, also in the various national institutes and labs, and that's important as well for the European model. So this whole activity was started in 2005, where the CERN Council acted as a council, not just for CERN, the lab, but also for European particle physics, as was already stated in the CERN Convention, and the appropriate quote is here. And it also defined this initiative, the update mechanism, and it was updated in 2013 and most recently in 2020. And as I said, it's a guide for long-term decision-making in the field with priority setting. It is not resource loaded though. So every big decision will have, every big project or new thing will need to be separately voted on to give it the budget. So in 2006, the first strategy report came out, and there, in a nutshell, the first and foremost priority was LHC, and prepare for the Hi-Lumi LHC, and do R&D for click and neutrino facilities, and of course, other priorities as well. In 2013, the recommendation was to exploit LHC to the fullest and also get really ready for the Hi-Lumi phase. It was not formally approved then, but that happened shortly afterwards. And also carry out design studies for the next collider at CERN. Europe looked forward to an ILC proposal from Japan. That was one of the high priorities, and also develop a long baseline neutrino program with the US and Japan. So now, after this 2-year process, the next update was on Friday, the 19th in June 2020, where the location was to be Budapest, but you know what happened. So it was an online meeting where unanimously all the member states voted in favor of the update, and that became then the strategy. And this was the culmination of 2 years of a lot of compilation, discussion, deliberation, etc. So who was involved in this process? Well, the main group is the European Strategy Group, which had 1 member per member state. Often it was the council delegate. So in Director General, 9 lab directors formed the Laboratory Directors Group, 5 from observer states and chairs of the astroparticle physics, the nuclear physics, the funding agencies, and their infrastructure organizations. The Secretariat, which did a lot of work and really guided the whole process. And also important was the Physics Preparatory Group, which I'll come to in a moment, consisting of Scientific Policy Committee members, ECFA, etc., and also 2 from Asia and 2 from the Americas, just to prepare the physics input for the strategy group to write the strategy. So the inputs were collected in the fall of 2018 with a call for contributions with a prescribed length, 10 pages maximum. Received not as many as Snowmass, but still a good number. And they were divided in all kinds. There were countries submitting the view from country X, from subfields, from neighboring fields, etc. All were brought inputs to the strategy. And this is always an important step in reaching consensus to make sure everyone feels involved. Besides with inputs also and these groups, also 6 working groups were formed on specific topics: social and career aspect for the next generation, global projects, relations with other groups, knowledge transfer, public engagement, and sustainability. And all of these wrote a separate report as well. So after that, already mentioned earlier, was an open symposium in May 2019 in Granada with 600 participants, overview talks, but not just general overview talks just for your general interest, but with the purpose of converging also to the physics briefing book that was input for the strategy. So a lot of parallel talks, lots of time for discussion, working group meetings, and that was a very intense, very lively meeting, I must say. And this led to this physics briefing book of about 250 pages prepared by the physics preparatory group on the basis of these inputs and the open symposium. And here it is on the archive. There's one book, and that was quite useful to have all together. It's still a good resource to look at for all these different fields, like the weak physics, flavor physics, dark matter, QCD, etc. So then after that, the final stage was a drafting session, and that was done at the Physics Center in Bad Honnef in Germany in January 2020, just before COVID struck. So the timing was very fortunate. We were with about 60 participants, lots of presentations, but particularly time for discussions, formulations. Every sentence in the report was discussed. The order of things was discussed. It was really quite intense. And sessions lasted long and finished after lunch on Saturday. And it must, for me, and I think for everyone, when finally, after this 2-year process, we all agreed on, okay, we agreed on this report to submit to council. It was a special moment, I must say. Here you see the strategy secretary, Helena Abramowicz. She guided the whole process expertly. So this led to the update. It's not a long document. Maybe you've all read it. This is a slightly more expanded version with more text around it. It is good it's good to be a short document and not 250 pages. It's really worth quoting from. And what it contains is 20 strategy statements, 2 on major developments from the previous strategy, 3 on general things to keep in mind, 2 statements on high priority future initiatives, and then on other aspects I'll get to also in this presentation that are also very important and not to be seen as fillers, but actually something that is acted upon. So with the preamble here, of course, to stating what is the motivation, what is the vision? Well, we need to look for to unveil the secrets of fundamental physical laws at very, very small scales and with high precision. So that led to the next facility being proposed as an E+E- factory for Higgs factory, and also go to the energy frontier eventually. So that's here in a nutshell, the European vision: prepare a Higgs factory, followed by future hadron colliders. That goes well beyond the LHC sensitivities, while also addressing the technical environmental challenges. It's also an important part of this sentence. So what were the major developments from the 2013? Well, you know them. First of all, to upgrade the LHC to the Hi-Lumi case and to actually make the neutrino physics program work. Other 2 high priorities were to do R&D for post-LHC, make our conceptual design reports for CLIC and FCC, and, as I said, look forward to a proposal from Japan on the ILC. Now, the LHC is certainly running well, so that's doing, after some COVID delays, so that part is really being done. The Hi-Lumi construction is well underway. I visited some of the tunnel work. It's really very impressive. The neutrino platform through which CERN participates in June in the US works very well, and the prototypes at CERN. It's the first time CERN participates in an experiment outside its own lab. So that's, in the meantime, also CERN has agreed to pay for the second cryostat at June as well. So there's a continuous strong involvement of CERN in neutrino physics in the US. Also in Japan through the T2K experiment. On the ILC, there's no further positive news. Chicken and egg has been named issue. It's been now so long that the egg must have hatched. So I think we're dealing with 2 chickens, but I'm not sure what it does for the metaphor, but we wait, we'll see if we can indeed, as Shekhar said, how to break the cycle there. And the CDRs are done for these future machines. Now, general considerations were that cooperation is a unique feature of the CERN model, of the member states, associate member states, and the non-member states in unique resources in science, human capital, expertise, etc. And also to share and develop cutting-edge technologies that is to the benefit of all. So this strategy update should be implemented to ensure Europe's continued scientific and technological leadership in this field. Now, all these countries have national labs here as well, and or not even formally national labs, but there are certainly labs that are involved in the global enterprise of particle physics, all with their own speciality. And it's good to have this ecosystem and not just concentrated things at one lab. So that's recognized here, that European research centers provide a large variety of technical platforms, have synergies with other communities as well. NICA, for example, half does particle physics, half does astroparticle physics. And it also allows European research centers, through the link to CERN, to gain high visibility, which helps sustain them, of course. So this ecosystem, unique ecosystem, should be strengthened, and that's another general consideration. But that's Europe, but particle physics is going global, so it is clear that the implementation of the strategy should proceed in strong collaboration with global partners, the US, India, I see, as part of Europe through CERN, and neighboring fields as well. I mean, so that's an important thing to keep in mind and to live by. So in terms of high priority future initiatives, I like this plot that Ursula Bustler made. It's full of information. If you study it a bit more carefully, maybe you've seen it in form of another, but every item has information. So there's the various types of possible future colliders, Japan, China, CERN, the preparation phase, the construction phase, the height of the box is the cost per year. There's a tunnel phase. So there's a lot of information in there. It's probably already out of date. It's 2 years old. Probably everything has moved to the right, not to the left. But you see here all the options that were on the table and also discussed. So the strategy felt that it is essential for particle physics in Europe and for CERN to have a new facilities after the LHC. There must be a flagship project at CERN for the viability of the lab. If there isn't, that would be, I think, very detrimental to its future. So there are two ways there, the Higgs factory and the exploration of the energy frontier. And so that those are also the high priority future initiatives to establish a Higgs factory. Which one is still to be determined. FCCEE at the moment is plan A, but there's other options. CLIC is a possibility for plan B, and then in the future go to FCCHH. And the main advice here, the main thing to follow up on was a feasibility study with such a collider. This little phrase generates a huge activity. So this study is well underway. There were committees, there was a steering committee, there's a collaboration board, all under the aegis of the council. Large set of topics to be addressed. There is going to be an important midterm review of the end of 2023 with a special council session early in 2024 to judge it and to take stock. And there's a lot of stuff that has to be done there, as many of you know. The governance of the feasibility study, but also deal with the legal aspect, the geology. There's a lot of stuff to deal with. Now, important part of this is, of course, how do you get those accelerators? And we heard talk just before that and the main effort here is the high field magnets. That is expected to take about 20 years to get up to 16 Tesla for niobium tin. 20 if you can do high temperature superconductors, but that requires a long research program. As a theorist, I asked also, what if you had twice the money? Can you do it in half the time? That is not the case. It's really, things take time. And but of course, other things are important in this R&D program as well. Plasma acceleration and muon collider, ERLs, all of these things we heard already talks about. The main charge here was to develop an accelerator R&D roadmap, which is now complete. It was compiled by the Laboratory Directors Group. It's been approved by Council, and now the implementation phase starts. We heard already about all the efforts there. So I think there's a lot of synergy to be made, perhaps also with the US in this. Particularly the high field magnets, I think there was a lot of synergy already, right? But there are other essential activities in most of the puzzles we have are often from astroparticles. The dark matter is one. Flavor physics is another that is very important. With flavor physics, you can look beyond the energy of the present collider through virtual effects. So here also there's a lot of vigorous studies already going on. Also in the physics beyond collider group, that's an important group. There's also things set at limited things. So for example, the beam dump facility and the LHE scene were seen as too expensive at this point to pursue. So this was not so good news for proposed experiment like SHIP, for example. The good news, of course, that the IISc is going to come, and that also has for LHC physics for all of hadron physics, an important impact through the impacts on part and distribution functions. A lot of these experiments are also done at national labs and smaller experiments, and my impression is, also in the Netherlands, the funding for these lower things seems quite healthy for these smaller experiments, in Europe at least. Theory is an important thing, also mentioned already by Shekhar. It has both formal aspects and, of course, these precision techniques, calculational methods that are increasingly talking to each other. That's a very interesting new development. And here already there is a global collaboration. Important to have resources enough here. Also for the long timescales that you need for these difficult calculations for building Monte Carlo event generators, do lattice calculations. But also theory allows, is a real source of inspiration for many students that I constantly observe again. And often the students come for the theory and stay for the R&D. And that's a great way to get people into labs as well. This is another very important one for the strategy. So detector R&D. Also here the charge was to start a roadmap guided now by ECFA and not the laboratory directors group. And here this was a very well executed process of getting the roadmap done, and this is now complete. It is now starting the implementation phase, and one of the new aspects is that detector R&D collaboration structures have now been defined. So on various topics, we heard about quantum sensing, and here I think there are also possibilities for India R&D to engage in these detectors, and to some extent already are, as far as I understand. So these are things that really came out. The feasibility study, 2 roadmaps have been done, and they really have consequences. They move the field forward. But the same is also true for computing. There's not a roadmap, but here progress is largely self-propelled. AI and all kinds of new techniques finding their way into particle physics research. We had talks on that, and also quantum computing increasingly shows up as a method for analyzing data, also for doing event generation. So it is profound R&D in its own right, not just a service. And here also there's an important aspect that experts need to be trained to address these things. We need to think about that and not just assume they will be there, but make it interesting enough the field for people to want to join also in this area. Another important neighboring field, which you also heard at this meeting, is nuclear physics. Nuclear physics enjoys many more facilities than particle physics does, such as ISOL, NTOF, FAIR, NICA, IISc, etc. All this is in Europe, and there's also nuclear physics facilities here and in the US. So they have that variety. Now, for us, for particle physics, there is the clear link through Isolde and Alice, and I think India is strongly involved there. And so here there is a natural link. We also had a nice talk by Vandana on this. QCD theorists are very interested in the EIC, of course. So there's also that theory link there with nuclear physics on that side. And now astroparticle physics is another very important one, and always a bit of a subtle one. Of course, if you think about it, all the fundamental challenges to our field come from astroparticle physics, dark matter, dark energy, the baryogenesis. So astroparticle poses the big questions to us, and what can we do about it? So these synergies need to be identified, and they're not just at the physics level, but also at the detector level, computing infrastructure. So there's a lot of cross-particle. Cross-field fertilization. That field has its own strategy, coordinated by APEC, and they seek strong cooperation, and CERN is also involved in that, but it is a little bit gingerly. There's a proposal to establish a new structure like recognized experiments, but it should be done in a cost-neutral way. So that is a bit of a boundary condition there. But in practice, this is overcome. For example, I know that the Einstein telescope has now offices at CERN, and CERN helps there with governance, civil engineering, and vacuum technology. So on the ground level, there is a lot of collaboration already. Of course, the field is getting increasingly global, and CERN is also here thinking about the governance. The same thing that Snowmass process was thinking of. One of the working groups was addressing this topic. So of the 6 working groups that I mentioned earlier. But there is now also a larger working group on governance of CERN, which has as one of its charges, what will be the governance in future global projects? So if you have, say, an FCC at CERN, you cannot deal with just the present governments. You would have major outside contributors, and they would want to say, so how do you go about that? That's an interesting question that we're now pondering. Conversely, if there is a large facility outside CERN, how do you go about that? That's a bit easier than most of the CERN member states would participate through CERN, but all of these things are still, of course, to be decided when the need arises. This is more on the general thing, but open science is important for making what we do accessible to the world, to also gather the information that the world has to offer. And so this is now more or less internalized, I think, by most of us. Particle physics is very fortunate that they don't have to think about it in practice too much, thanks to the Scope 3 agreement that lets you use the usual journals, and it is open source. But it is demanded by funding agencies. And so I don't know how it is in India, but we have to publish in open science journals. And not just open publishing, but also open science in other fashions. And CERN, of course, is being the birthplace of the World Wide Web. This is nothing strange to CERN. It was also mentioned in Shekhar's talk, energy is an important thing. And anyway, the relation of particle physics to climate change. Now, it was a bit unfortunate serendipity. One advice is to reduce travel. Now, that happened very quickly after the drafting session. Travel just stopped. We learned new ways of meeting. Now, the significant efforts now at CERN going towards sustainability on many, many levels. So CERN is really making an effort there. And energy is now a major cost factor. CERN has green energy in the sense that it's carbon free because they get all their energy from France, which uses nuclear power stations. So that's in some sense it's green. But the energy is a major issue, major concern for the future. An even bigger major concern, perhaps, is how do you get the next generation involved, as said, especially given the long time scales, and how do you go about it? That's not an easy question. The field is mixed. I've heard input when young people in the UK were asked, do you mind if the accelerator is that far in the future? And they didn't mind all that much if the work on the way was interesting enough. So it is not necessarily an enormous hill to climb, but it must seriously be thought of, and perhaps many answers must be possible. It is important here that, of course, equality, diversity, and inclusion are part of the process and really visible, so everyone can participate. Make careers also possible, also not just in science, but also in R&D. If you want to do detector R&D or computing R&D, there should be a career for you, and you should be able to get recognition for that. That was a major topic of attention. Knowledge transfer, that's also important, of course. CERN has a dedicated program for that, and always when we visit CERN, there's always a talk by the knowledge transfer department. And important to have good relations with industries, and certainly for us, industrial liaison officer is key to this, that makes the link between industry and our field. And this could be perhaps an idea for India. In the Netherlands, we have a business incubator center that really is a site where these things are made naturally. And perhaps this is a possibility to consider here. And of course, public engagement, very important to keep people interested in what we do. My feeling is actually particle physics is doing very well here. We shouldn't stop, we should continue, but I think we're way ahead of many other subfields in physics. At least that's my interpretation. And we have a lot of activity already going on there. We should keep that. So what are then the next steps after this? As I said, the strategy is now more than 2 years old. As I said, CERN uses a strategy to allocate its resources, and it does that through its medium-term plan, which is always now plus 5 years in the budget. And really, the items from the strategy are identified in there and get money. The magnet field research, the muon collider, the CLIC gets funding, et cetera. All the major parts in the strategy get funded in that way. The LHC program is on its way to forward again, and the Hi-Lumi upgrade is also moving forward, as is the feasibility study. Of course, Council had to deal with the energy crisis, has to deal with energy, and that's not solved yet. That's a major challenge. And we have still the crisis that one observer state was aggressive to a member state, so that's a major problem. On the more positive side, the roadmaps in R&D for detectors and accelerators are being implemented, and there's lots of activities going on there. And there's very good progress on the other goals, the transversal goals that I mentioned. The next update, that will be an important one, because that will reach a decision on the FCC and whether it will be plan A, B. So that's something we need to keep in mind and be engaged with. I think that would really set the stage for the future, and not just for CERN, but perhaps globally. That was all I had to say. Thanks.
Thanks, Eric. Your wonderful talk, not only the science, also the surrounding things related to our science. Yeah, now the floor is open to the question or comment.
Thanks, Eric, the great talk. So I have lived on both sides of the Atlantic, and I know how things are done very differently from the European strategy and the SNOMAS. But I want to address the two things you mentioned, is this business about sustainability and energy, and the other thing about culture change, about time scales going longer and longer. And we're talking about 100 years kind of time scale on how to motivate the younger people.
Right.
So we have a working group 14 in IUPAP, International Union for Physics and Applied. We are discussing these two issues with ESS, European Spallation Source, as an example for zero carbon footprint facility. And so that is, accelerator people have to work hard on it, how to make it happen. Right. It's on us, not on you guys, not particle physicists. And the second thing is actually we need help from particle physicists about why the project can be on a 100-year time scale. We must provide low-hanging scientific fruits so that younger generation can see, while the bigger goal is over there, but on the way we get a lot of things. And that we have not done very well in the last 50 years. So we need your help in doing that.
So on the last part, I ask people now and then, what's your view on this? And one or two people had this interesting notion of not just being part of an experiment, of one experiment, but perhaps of a particle physics one and a smaller astroparticles one at the same time, which is much shorter time scales. It gives a variety, it keeps you interested. How to organize that is perhaps complicated, but I think if you think about it a bit more creatively, that could be a sort of thing. It's a bit like when the LHC was being built, people were a member of Babar, of D0, etc., and at the same time of Atlas and LHCb. So you can do things along the way. Indeed.
So I mean, accelerator people is easy to do because we get little magnet, a little RF, a little laser, but the particle physicists have to also get something out of it. And that's the thing, it's hard. I mean,
I know.
Yeah.
We need to talk about it.
Absolutely. Right. Okay. Thanks.
I have a question on the feasibility review that you were mentioning that is right underway. Were there any goals set that should be reached? Or was it, say, you do the evaluation and later we see whether we think that's okay? I guess it also concerns financial costs and technical feasibility, for example, magnets, etc. Yeah.
Right. I think it's this clear goals. I mean, I mean, the tunnel is a big thing, of course. But how do you deal with the tunnel, with the geology, with the legal framework around it, with the outreach around having tunnels going underneath here and an accelerator going underneath? about the financing plan. How would you go about it with possible outside contributors? CERN cannot pay this from its own budget. We need outside contributions. So yeah, it's going to be fairly concrete because the member states want it. They want to have they want to have an early view of whether they can get their governments ready to provide the extra funds needed for a while for such a new machine. So it must be concrete, absolutely.
Hello, regarding the knowledge transfer.
Yeah.
So it's like an open source, or it comes with a fee from CERN?
I think it's mostly open science, as far as I know. Certainly, anything that goes from CERN to a company will be open. Right? That's just enshrined in the rules. It could be that I'm not sure if that's a knowledge transfer topic. Of course, you can, if you procure something from a company, it can come with an IP, I think. But I think the idea is that it's open, absolutely.
I had two small questions. You said that the states like India and so on, they pay 10% of the member states.
Right.
But what is the fraction that the member states pay of their GDP?
Oh,
is it like 0.5% or no?
Oh, I don't know.
Or maybe even smaller, or what is it?
Well, I just need one country to calibrate, right? So it's not half. It's much smaller than 0.5%.
Much smaller.
Sorry?
No, is it much smaller or larger?
Much smaller than 0.5% of the GDP.
Okay.
I think it's at the order of 10 to minus 4.
Okay, the others. Okay, maybe we can discuss it. I can ask.
I know the Netherlands pays 50 million. The Netherlands pays 50 million Swiss francs.
Okay, I think this this discussion we had, I think way back in 2010, and the CERN budget is basically maintained by the member states in proportion to their GDP.
Right.
For the at that time India suggested that we should not pay in proportion to our GDP, but at some fraction, and it was discussed a bit, and we eventually came to that 10% level. So that we pay 10% of what we would pay that's right. If it was in proportion to our GDP.
That's also the minimum. So you cannot go below 12%.
Okay, that is the minimum.
Yeah.
I mean, you could pay more, but not
that's
less
right.
than 10%.
And a few countries pay more because they're on the way to full membership. And then there's a few years where you have to ramp up your contribution.
Well, that was a different thing. But you would start with at least 10% of what you would have to pay if you were paying your full contribution according to your GDP.
Absolutely. It's at least 10%, and surprisingly, most countries pay just 10%.
Another small question. With regard to your open access journal, so who pays actually for the? Is it
so this is the scope 3. It's actually the library fees, and it pays from library fees. So you don't pay author processing charges.
You pay for that.
Yeah. So you don't pay author processing charges. The libraries do it for you.
Oh.
Yeah.
Can I?
Okay. So I just checked. So the British GDP in 2022 is £559 billion. The contribution to the CERN budget, approximately 100 million. Right. So you're talking about 2 per mil. Sorry, 2 times 10 to minus 4.
Okay.
So your estimate.
First approximation is just right.
Yeah.
I read somewhere that when the American public was asked, what do you think a fraction of the budget goes to NASA? Most people estimated 10%. So people are usually fairly off these numbers.
Okay, right.
You mentioned something about the member states wanting to be prepared for the extra contribution towards the project like FCC. So does it mean that for that period and for that project, CERN would ask member states and associate member states to increase their contributions? Is that what is foreseen?
Probably, but if it's for the tunnel, I doubt you're going to get extra contributions from countries that don't contain the tunnel. So I think there the expectation is the host nation, Switzerland and France, and perhaps external contribution from the US could help. There has been mention of that.
Okay.
But that's but not from. I don't think other countries would readily pay for that.
I was just curious. Yeah. That's why I was curious.
Okay, I think no more question. Thanks, Eric, again.
Okay.